Hello, today we are looking at word problems and how you can solve them using systems of equations. Now, I'm actually going to start with what sort of word problems use systems of equations. And the sorts of word problems that use systems of equations are word problems that describe and compare two different situations and or two different topics. And we're really looking here at mostly the totals when it comes to that part. And we're going to be able to solve these systems by examining these word problems and looking for two variables inside of each one. We're going to identify the totals you could make with those variables and use that information to write two equations. Once we have the two equations, we're kind of back onto our normal ground and we'll start solving using systems of equations. Now keep in mind, what we're really doing is we're adding these steps to what we've done already. So if you can get to this stage, you'll still have a lot of work to do, but that doesn't mean that you have a new concept to learn. So just be aware these will take time, but this is the only new thing that we are doing. So let's take a look at how to do this. Well, first let's read through the problem. In 1 week, a music store sold 7 violins for a total of $1,600. Two different types of violins were sold. One type cost $200 and the other type cost $300. How many of each type of violin did the store sell? One thing that's nice about these is usually the question itself will tell you what variables you are looking for. We want to know how many of each type of violin the store sold. That means our variables are really the two types of violins, which we can label A and B. So I need to find A and B, how many of each type of violin we sold. So I'm going to look back through here and I'm going to see what information I have. Well, first off, I know that the music store sold 7 violins. And that means in total, there were 7 violins in that week. So this right here is a total. I also know that they sold a total of $1,600. So that's another total. That means that these two things are going to be the totals of our two equations that we have for our systems, because each equation will have its own total. Now I just need to figure out how they got these totals. And remember that these two things are different situations. So I'm going to look for information as to how I can figure out that they got 7. That one's going to be easy. And how they got the total of $1,600. And it's nice to remember what these refer to. 7 refers to the number of violins. And 1,600 is talking about money. Well, I know that A and B describe how many of each type of violin. That means that if I'm looking at a sale of 7, I have taken the number they sold of A, added to it the number that they sold of B, and I've gotten 7 total violins. Now the other thing is the money, 1,600. I know in order to get this, what they did is they took the amount of money they made off of one violin, added to it the amount of money they made off of the other type of violin to get this total. And here, this is where I'm going to have to just look at what I know about writing equations. I know that when something costs $2 per item, what I'm doing, or $200 per item, what I'm doing is I'm taking 200 and multiplying it by the number that, or the number of violins that I sold, because this is a rate. We typically call them slopes when we're talking slope-intercept form. It's paid repeatedly, once for every single thing sold. The same thing is true of the other one, 300. 300 is going to be paid repeatedly, one for every violin sold. So that means that 300 will get a variable as well, B. So at this point, what I have is I have a system. I have two complete equations with each one coming to a set total. If I have this, it means I can solve this using systems of equations. So what I will do is I'll set this up like a normal system, A plus B equals 7. and 200A plus 300B is equal to 1,600. And I can use substitution, elimination, or graphing to solve for A and B. If you missed class, I would like you to do this on your own and show me the solution, along with the second one, which I'm going to walk through with you for setting up the equation. So let's get the second one started before you can go back and solve the other system. Or if you want, you can pause the video, solve the first problem first, and then come on down to the second one when you are done. Let's look at this one then. We know that the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair and $5,050 was collected. How many children and how many adults attended? Now keep in mind the question often describes the variables. I want to know the number of children, which we can call C, and the number of adults, which we can call A, that came into the fair. When I'm looking at my information here, I know that they charged $1.50 per child, or for each child. That means that this is a rate. So that gets a variable. $1.50 per child would be $1.50 C. And $4 for adults would be 4 times A, the number of adults. So what I have here is some of a piece of an equation, but I don't have my totals, which is what I really want. So let's continue with the problem. On a certain day, 2,200 people entered the fair. 5,050 is collected. Well, I know that 2,200 is the total number of people. And I know that this money is the total number of money gathered. So that means that I have two totals. And if I have totals, I can write equations. 2,200 when we're talking number of people, and 5,050 when we're talking money. Now, in order to get 2,200, what I know is since that's the total number of people, and our people are either children or adults, all I'm doing is taking my number of children plus the number of adults, adding them together to get 2,200. On the other hand, when it comes to money, that takes an extra step. You get $1.50 per child. So in order to figure out how much I made off of the children attending, I would take 1.5 times C, or 150 times the number of children. I would add to that the money we made off of the adults, which would be $4 times A, those rates, and notice that this is the equation that I end up setting up. So this again needs to be solved, and you can do that off to the side. In fact, that's what you will be doing along with number 1. So your homework for today is to finish up the worksheet that you guys ended up with in class, and if you missed class, complete these 2 problems and make sure to check your answers using the techniques that we learned in the past. We're going to be continuing word problems tomorrow. I hope y'all have a wonderful day.